Hello, hello. Welcome to section 7.5, solving trig equations. Kind of getting rearing to go here. Pretty exciting these times, these last couple of sections, or sections rather, as they will try to kind of summarize everything we've been doing for the last, month and a half with all this trig. So we're going to use the right triangle trigonometry and the normal graphs of sine and cosine and the unit circle. We're going to use everything to start solving for some things. And next section, I think we're going to probably get into some applications. So before we do the applications, though, we're going to work on solving the actual problems by hand. And so we can go ahead and check out the learning objectives again if you want. First video here, we're just going to try to get through a handful of problems just to get you guys familiar. I think you're seeing kind of the pattern of things where I'll start on one and then give you a shot to do it. So play along. Um, and so what we're going to do, at least in this first video here, we're going to try to solve most of the trig equations that are linear. That means that they only have a power of 1. And we'll get to that in a second. We're also going to do quadratic ones and then do more identities improving and then start doing trig equations with different angles too. So you can even read in this about it's kind of like the capstone of the whole part of the class. So it's a big deal, this section. And like I said, the best way to get good at it is just to do problem after problem after problem. So it's a big section. Make sure you understand it. And let's just get to it. So now's a good time. If you have not done your chart in 2 circles again, pause the video, do the chart in the 2 circles as fast as you can. At this point in the semester, you should probably be able to get through I'm charting the 2 circles in about 2 minutes if you're moving. So pause video, go ahead and create those. I have mine already up. And when you return, we'll get going. Okay, I'm assuming you're back. And let's go ahead and just dive right in and do example 1 here, which is going to ask you, I have some weird things popping up all over. It's going to ask you to find the solutions to cosine of theta equals 1/2. Now, we've been working on inverses and such, so we should be okay at this point to know that now, well, before I even go there, remember, this is an angle. I'm going to ask you on the midterm. The trig functions take what as an input, and the answer is an angle. And then I'm going to ask you, what did they spit out here? And you're going to tell me that ratio. So, or not the 1/2, but the word I'm looking for is actually the ratio, the word ratio. And when you do the inverse of it, remember you're taking in the ratio and you're reversing the process so that you can spit out the actual angle. Now be very careful. If I'm drawing my unit circle here, when you do inverse, especially for this one, inverse cosine, you can only go, if you remember, your range of answers for your first answers, because there's a zillion answers, but so that everybody gets the same first answer, our answer has to be between 0 and 2 pi. So let's go ahead and try this one out. What angle, and if you're looking at your chart in the 2 circles, gives you 1/2 for cosine? And you should be looking at your chart by now. It's probably, I think, 60 degrees in your chart. And I was not fooling around. I do have my chart in 2 circles up, which you guys can reference if you want. You should be able to see that. So 60 degrees, or pi over 3, is going to give me cosine of 1/2. Well, okay. What do I do now? Well, once you're there, I'm trying to go back to this now, and I'm getting lost in my screen to switch. So what do we say? 30 degrees? And I don't care if there's no instructions on what form to put it in as far as degrees or ratings, you can do either. So my answers are going to be 30 degrees. Now, if you were going to do that in terms of radians, you'd say pi over 6. Either one of those answers is totally acceptable. All right. Now, that on a unit circle, if I'm really showing all my work here, and I'm sorry, I said 30 degrees. I should have said 60 degrees. Let me correct myself. I don't want to redo this whole video just because I misspoke. But it is 60 degrees. I'm sorry. Or pi over 3. Boy, that would have been a big goof. Now, what that's really saying is for an angle of 60 degrees over here, and now let's just use green, that this distance here is 1/2. You guys should be okay with that. Now, the other problem, though, remember, cosine's always x, sine here is going to be y, so there's y, and we'll call this x. So x is 1/2 of that triangle there. But as you rotate around, now remember, that's your first answer, so you can call that theta 1, either one. But the other thing that you have to consider is that they're asking you to find all the solutions. So as I'm going around the unit circle and I keep going, you can rotate around all the way to where you have a reference angle of 60 degrees there. Hopefully you understand what I'm saying by now, which means you can rotate 300 degrees to get yourself at this spot in the unit circle, which will give you the same answer. All right. The only thing that we're going to do to start every one of these, though, is we're going to give the first answer as far as in the range of answers that are allowed because of the limitations. And then we got to get all the others between 0 and 2 pi. So the other answer between 0 and 2 pi was, well, here's my theta 2, would be 300. Now again, you could say 5 pi over 3. Same thing. So that's theta 2. I'm being a little sloppy, but do you guys get what I'm trying to communicate to you? So now that would be fine if they wanted all the answers between 0 and 2 pi. But in this case, you got to be real careful, and I need to leave myself a little bit more room here, and you'll see why in a second. If you're being asked for all of the angles, well, what happens is, is you can keep rotating. See if we can follow what I'm saying. That at 60 degrees, and if I do this in black, you can come up here one rotation. But if you go all the way around 2 pi, you end up at the same spot. So that's one rotation of 2 pi. So the way to account for that is say 60 degrees plus 360. What happens if I go again and again and again? So what you see in the textbooks, and for this one, if you're asked to find all solutions, you're going to be required to say, hey, it's 60 plus any more times around the circle, which is 360 degrees, times how many times you want to go around. Get it? And that's going to hold true for this pi over 3 version. If it's in radians, you can just say 2 pi times n. That accounts for all the solutions, and that's really, think about how many more solutions you're doing by accounting for the 2 pi n or the 360 n or the multiple rotations. There's a zillion of them. So really 60 degrees is just one answer. And if you're going to do 300 degrees, you can still do 360 n or plus 2 pi n for those as well. So you're going to need those in there when you're being asked to find for all solutions. Okay? So we've done that one. Let's go ahead, get down here and skate down and do, excuse me, the inverse. Well, I'm already telling you what to do, but find the angle that gives me negative 1/2 for sine. Well, in other words, what angle will give me negative 1/2 for the sine function here? And again, if I write it like this, oh, negative 1/2, I'm looking for some angle t. This time it's not a Greek letter. And I should also tell you, excuse me, that you might see in the future something called arcsine. Arcsine means inverse sine. It's the same thing. It's not on your calculators or anything. I could have written up here arc cosine of 1/2 as well. Notice that 1/2's positive, this one's negative. So if you see that in some of the textbooks, don't be alarmed. It just means reverse the process, do the inverse function. And since we have a lot of room, let's put my circle down here this time, my egg-shaped circle. And remember, when you do inverse sine, you can rotate up pi over 2 or backwards pi over 2. And again, it's asking you for this distance here. Green is this side. So in other words, let's see if I can draw my triangle the right way here. But really what you want, this is going to be negative 1/2. Remember, cosine's always x, sine's always y. And for these ratios that are coming up, you're going to look for this angle t. And remember, the other angle t that gives you 1/2, if you're looking at your your chart, and I'm just going to skip over going to look at it, but it should be 30 degrees. So you can go 30 degrees in the positive direction, but really to give you the negative 1/2, your answer for this is t's got to be, and we're only going to do one version today. Let's just do, well, we're doing degrees, so minus 30 degrees. Okay? Now, that's my first answer, but really, as I'm rotating around in the positive direction this way, it's 30 degrees or minus 30 degrees or positive 30 degrees will give me the same, oh, excuse me, that's not correct. What the heck am I saying? And the reason I'm checking myself is notice this is negative 1/2 right here. This is 30 degrees of 1/2, which is what I use to get this minus 30 degrees. But the other triangle that you're going to want, so we can draw it right over here. I even get fouled up as I'm talking sometimes. My hand and my mouth, they don't match up. But that's going to be negative 1/2 as well, with the angle of 30 in here. I don't really care if you say minus 30. If they say give me all the angles, that's not typical, plus any rotation of 360, because they want all of them again, times however many times you're going around. Or you could go, if I'm starting here, once I figured out what that angle was, right? I got my first answer by going down here. If you're going around here, what's that, 180 and another 30? So this is going to be 210 plus, in other words, 210 to here, which gives me my negative 1/2, plus however many times, that's 360, another 360. So notice you could do it this way. Those two are your answers, and they account for all the solutions. Or sometimes people don't and aren't comfortable with that as a final answer. So what they'll do is they'll say, hey, this is my first answer. So they'll say time 1 is equal to 260 degrees plus 300. Don't forget the degrees, otherwise the default is radians. And then they'll say T2, instead of using the negative here, they'll come all the way around to, oh, I think it's what, 330? So you can say 330 degrees plus 360 degrees in. And again, if you were in radians, you could do that for radians as well. I don't care which way you do it. Sometimes, and really, what will dictate how you're going to do all of this will be how the question is phrased. So if they're asking you to find all the solutions, and let's just go ahead and T1 and T2 do this in radians as well. We'll do it in gray. So in radians, 260 degrees, remember you're going in 30-degree increments. And if I'm going in 30-degree increments, right, or pi over 6, then 1, 2, 3, 4, 5, 6, this is going to be 7 pi over 6 plus 2 pi k. And then excuse me, I need to write that up in the other blank. So fun to have to mess with technology all the time and fight the computer. And 7 pi over 6 plus 2 pi k. And then the other one, try to do T2 for me since I put it in the wrong spot here. T2, this, right, would be 11 pi over 6 plus any full rotation times the number of time you're doing it. So this one's in radians, this one is in degrees. Okay, that's the first page. And what will happen is all the other problems will be very similar from here on out. Now, sometimes you won't have to work as hard. For instance, this equation here, for example 3 says, hey, and this is again is the most important part, on that from 0 to 2 pi, you're looking for all the angles. Whatever angle's in here, to give me an answer of 1 there. Now, theta minus pi over 2, whatever that angle is going to have to equal 1. Well, if I go over to my chart again, notice the tangent of what gives me 1? What angle would give me 1? And if you're saying, oh, well, that's just pi over 4, you'd be correct. So keep that in the back of your head for a second. Pi over 4, so the tangent of pi over 4, in other words, this needs to be, Sorry, here goes my computer again. This angle here needs to be pi over 4. So watch this trick that I'm going to do. It's kind of a cheap trick, but I'm going to say, hey, if this whole thing, and let me erase one more time. But I'm going to say, if this in here, theta minus pi over 2, if I set that thing equal to pi over 4, I should be able to find my answer. So add pi over 2 to both sides. So theta is going to be pi over 4 plus, now let's get a common denominator, times top and bottom by 2. So 2 pi over 4. My theta is going to be 3 pi over 4. And that's your answer. Now, remember, if you want all the angles between 0 and 2 pi, though, 3 pi over 4, right, is only in the first top half of that circle. You can add, and here's the thing, the period of tangent is pi, right? Like sine and cosine were 2 pi. But in this case, so you're going to have this 1 happen again if, so there's a first angle, and your second one's going to be 3 pi over 4 plus pi radians. Not bad, huh? Okay, so let's talk about one other way to do this that's coming up. All right, another way to do this, and let's go ahead and I'll erase these angles here just so I can have, let's go back to this example 2 for a second. This is what's coming in section 7.6. There is another way to look at this in terms of when you plot, again, here's my problem, just revisit this. What's the sine function look like? Or actually not even that one. Let's do cosine. Put all those other angles back up there. Watch this happen. This is cool. I apologize for making you wait. I'm changing my mind as I'm talking to you. I just thought it might be a good idea for the time being to show you a different way people are doing some things. That's all. So if I go back to my pens here, my computer's just not liking me. And gosh, look at example 1. We'll do that one. That one might be a little bit easier. You're looking at example 1 and you plot that. Notice from 0, gosh, I don't know if I'm going to have enough room here. Here's pi, here's 2 pi, and this will be, I need more space, and I know I'm going to need more space. So I'm sorry I'm making you kind of struggle watching me through this. Let's do this one more time. So thank you for your patience. But let's make this to 2 pi, and this to pi, and this 0. And remember, if you're going to do this, all the spots, the poles, are the quadrantal angles on a unit circle. It's pi over 2, 2 pi, 3 pi over 2. You guys remember? And if you were going to do a graph kind of here, you could put, remember, you start up high and get good at being able to mimic what I'm doing here. Okay, it's not a perfect graph. Let's call this the cosine graph, cosine theta. Now, if the question is, just like it was here, when does that thing equal 1/2? What it's really saying visually, if you do it this way, is when is that thing going to cross here and here if this is the line y equals 1/2? So where there's those two cross, and notice they cross before pi over 2 and after 3 pi over 2. And if you want to do that, notice before pi over 2, right? So they cross here, and after 3 pi over 2, they cross here. So right before it gets to 2 pi and right after 0, those rotations are represented in a different manner here. And if I really wanted to know that answer, what you do is you take this, and that's your answer right here. So that's going to be that angle we found, that pi over 3. And remember we did that as the first answer? So pi over 3 would be my first answer. And then if I wanted my second answer, I don't even have to do anything. If you're doing it this way, you can just do 2 pi over, excuse me, this answer here, because it's symmetrically equivalent, like you're going to go just as far forward as you are backwards here. You can do 2 pi minus pi over 3. And again, if you wanted to crank it all out, that's just 6 pi over 3 minus pi over 3, or 5 pi over 3, which was our other answer over here. 5 pi over 3, I erased it, right? Plus 2 pi n. So either way you do it, and if you don't understand that quite yet, that's okay. But remember, you can look at this in a different manner. It's very important to be able to put those hash marks and be able to create both those graphs. So that's just a glimpse into the future. That's coming. Okay? All right, 3 examples down. Let's do 2 more here and we'll call it good. My headset cuts out on me, that's okay. I'll just turn it back on. So remember, there's not really a cosecant button on your calculator. So the way to do example 4, now notice they want all the rotations between 0 and 4 pi this time, is just to kind of transform that into something a little bit more familiar. Now if I cross multiply those things, what that's going to end up being is sine theta equal to negative 1/2. Well, and if you remember, and this is why I put those functions back, because we already did this one, what angle is going to be negative 1/2? Or sorry, sine of negative 1/2 gives what angle? So you can do that all over again. Remember, your first angle was here, right? But in this case, now, hopefully you're okay with that. Please remember that my first angle, because of my limitations, because you can only go up a quarter turn and down a quarter turn, or from pi over 2, it's there, it's just scribbled all over, or down pi over 2, that our first answer was minus 30, or you could say minus pi over 6. We cannot use that as an answer, though, and that's because it doesn't lie in the range of answers that they want. So, headset just died. What I'm trying to tell you is that these answers here are probably best. So in other words, what are the angles that give me sine of, or excuse me, a negative 1/2? It's this 7 pi over 6 and 11 pi over 6. Now because, well, let's put that in there first. So I'm cheating, I'm using the other problem, but my first theta is going to be 7 pi over 6. My second theta is going to be 11 pi over 6. Now, because they want one more rotation, you can go ahead and put theta 3 equals, we're going to take the 7 pi over 6 plus 2 pi. We don't have to put the k because we're not going around anymore. And my fourth theta is going to be 11 pi over 6 plus 2 pi. So that's how you get those 4 angles. Again, we kind of cheated. You could say, if you wanted to see it written a different way, arc sine of negative 1/2 equals theta. Remember, that's the same thing as saying inverse sine, taking in the ratio and figuring out the angle, and then going from there. Now make sure you do this on your calculator too. We're in radian mode here. If you're getting all these pi's and there's no degree symbol, you should get out a decimal approximation. And if you do it that way, you'll be able to not only do the decimal approximation there, but when you hit your answers for all 4 of these, you get the same, the same decimals for each one when you do an approximation. Be careful. I used to only get the first 2 answers, and if I left out those 2, I'd only have half the problem right. So in some regard, this is almost the most important part of every problem before you even get to the problem. Okay, let's do example 5 and 6 on your own. Excuse me, 5A and B on your own. And then that'll be the end of this video here. But pause the video, try to knock those out. And when you're done, I'll show you how to do them pretty quick. Okay, pause the video. Please do it on your own. Give it a shot. Go. Okay, if you're back, quick for me. Hopefully you worked hard. I'm going to move that 3 over. So if I add 3 to both sides, you end up with 2 cosine of -2. And there's my theta. Don't leave that out. And now I have a new problem. Cosine of what angle is going to equal -1? Or if I write it with the proper terminology, what angle gives -1 for cosine? And if you're telling me on a unit circle, if you remember, -1, 0, cosine's always x, that answer is just pi. And when you're at the poles, sometimes it's kind of special because if I go around again, so I rotate around pi, there's nowhere on the other circle. You could rotate around again, but that would be 3 pi for another answer. And because that doesn't lie between 0 and 2 pi, it would be incorrect to actually throw that out there and offer that up. So make sure that your answers, that's what you're going to be responsible for. If you give me 2 answers, you got to take points off for the answer that you thought should have been there. So again, everything hinges on that. Okay. Now, same limitation for part B. And if I start doing that, and just for fun, I'm going different color. I'm going to have 2 sine of some angle theta equals -2. Oops, sorry, -6. Divide both sides by 2. So, what angle can give me -3 for an answer? Now, careful. You can't do this. There is no angle. Remember, the normal range of answers for sine is from down to -1 to 1. So because of that, there is no solution. So this is your answer here. You don't have to do any more work. Pretty cool, huh? Okay, there's the first tough one. If you need help on any of this stuff, please, and you will, don't feel bad. This is the hardest part of the semester. Come find me in Math Lab or talk to somebody else in Math Lab. Watch the videos again. Watch the related videos or even go to YouTube and watch some more videos. All you have to do is type in the topic at the top of this page where they start talking about solving trig equations. Okay? This stuff is tough. Moral of the story is find all the solutions, not just one, all the solutions in the range of answers that they're looking for, or in the domain of what they're looking for. All right, take care.